Alright, so this is the notes for 12.1, and I'm going to split this into two parts because 12.1 has to do with the distance formula and the midpoint formula. So I'm going to focus this video just on the distance formula. So these will be the notes for 12.1, part 1, the distance formula. Alright, so let's start off with deriving the distance formula. Where does it come from? Let's suppose we have these 2 points in space. I'm going to call this first point right here P sub 1. And let's just call it x sub 1 comma y sub 1. So this x value here that goes with this point is x sub 1, and the y value that goes with it is y sub 1. And let's say we have another point over here in space. Let's call it P sub 2. And that point's going to be x sub 2 comma y sub 2. Okay. I'm going to get rid of my grid marks here because I don't want you to think that we can actually find the distance by counting up the grid marks and finding that distance. I want you to think that we don't know what x sub 1 is and x sub 2 is, and we don't know what y sub 1 and y sub 2 are. So I'm looking for the distance between these 2 points. Right here. And let's say I don't know any way to find this, but I do know another formula. I know the Pythagorean theorem. I could use the Pythagorean theorem to help me find the distance between these 2 points. I could form a right triangle here. Okay, so let's say this is a right triangle. So if I could find this leg of this right triangle, and I could find this leg of this right triangle, then I would be able to find the hypotenuse of this right triangle. And I can do this. I can do this by subtracting these distances. If I subtract these x values, it's going to be x sub 2 minus x sub 1. That's going to give me this distance right here for this leg, x sub 2 minus x sub 1. And if I subtract the y values over here, that's going to give me that green distance, that green leg. So that's going to be y sub 2 minus y sub 1. Now that I found the legs of this right triangle, I can actually find the hypotenuse. So the Pythagorean theorem says if we have a right triangle and let's say the legs of this right triangle are A and B, we can find the hypotenuse C by adding a squared plus b squared and setting it equal to c squared. That's the Pythagorean theorem. So let's go ahead and do that. So let's call this over here D for that blue distance that I'm looking for between P sub 1 and P sub 2. So that's going to be D is equal, D squared, I should say, D squared is equal to x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So I'm trying to find D. I'm going to take the square root of both sides. Square root of D squared and the square root of all of this. Now when we've been doing equations and we've been solving for equations, when we take the square root of both sides of an equation, there's always a positive and a negative value. But we're going to disregard the negative value in this case because it's impossible for a distance to be a negative value. So I'm only going to take into account the positive value. So D is going to equal the square root of x squared minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And that's my distance formula. Okay, so let's write that down a little bit more formally as a definition. Alright, so the distance formula says that the distance between 2 points p sub 1 and p sub 2 where p sub 1 is equal to x sub 1 comma y sub 1 and p sub 2 is equal to x sub 2 comma y sub 2 is the distance between p sub 1 comma p sub 2. And we can also think of this as a function. So I could also call this d of p sub 1 comma p sub 2 is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Let's do an example. Find the distance between p sub 1 equal to negative 3 comma 2 and p sub 2 equal to 9 comma negative 3. So the first thing I like to do when I'm finding a distance, I like to label my point because it's very easy to get confused when you're substituting into the formula. I'm going to label the first point here as x sub 1, y sub 1, and my second ordered pair as x sub 2 comma y sub 2. And now we're ready to substitute into my formula. Let me copy my formula down again. The more times you copy the formula, the easier it's going to be for you to remember it. D is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So this will give me D is equal to 9 minus x sub 1. So my x sub 1 there is going to be negative 3 quantity squared plus negative 3 minus 2 quantity squared. Alright, so this can turn into, when we're minusing a negative, we're actually going to add, so I'm going to just turn that to addition. So D is equal to 12 squared plus negative 5 squared. And that's going to be the same thing as the square root of 144 plus 25, which will give me the square root of 169, which is just going to be 13. So the distance is going to be 13 units from p sub 1 to p sub 2. And that's how we find our distance between 2 points.